Okay, in today's class, we are going to look at static routing. Previously, we looked at routing concepts and how routing is done, why we need routing, what types of different routings there are. But today we are going to focus on static routing. So these are the sections and objectives which you can read in the slides. But basically, in a nutshell, we're going to look at what is static routing, how to configure and verify the static routing, and then we're going to look at troubleshooting some static routes problem. So static routes are commonly implemented on a network. This is true even when there is a dynamic routing protocol configured. That means they coexist. It doesn't mean that a network topology would only have dynamic routing or only have static routings. They can have both at the same, within the same topology. So static routes can be configured for IP version 4 and IP version 6, which we are going to look at today. And both protocols support the following types of static routes: the standard static route, the default static route, the floating static route, and the summary static route. Static routes are configured using the IP route or the IP version 6 route global configuration commands. This command, IP route and IP version 6 route, is basically telling the router that we are now going to configure a static route. So IP route means we are configuring an IP version 4 static route. IP version 6 route means we are going to configure an IP version 6 static route. When configuring a static route, the next hop can be identified by either an IP address, an exit interface, or both IP address and exit interface. Okay, so next hop route is the next hop within the cable. Okay, the next hop IP address that is specified. Directly connected static route is only the router exit interface is specified, and in fully specified static route, both next hop IP and exit interface are specified. So if we call it the next hop static route, so we need the next hop IP address to be specified. If we call it the directly connected static route, you need the exit interface to be specified. If it is called fully specified static route, you need both the next hop IP address and the exit interface to be specified in the configuration. So let's look at an IP version 4 static route command. We start in the global configuration mode, which you can see here with the prompt router config. This tells us that we are in the global configuration mode. And in there, we type IP route. And this command tells the router that we are preparing to configure a static route. This is the remote network address, okay, the remote network address, and this is the subnet mask of that remote address. And then this is either the IP address or the exit interface, and there is an option for a distance. Okay, this distance here is administrative distance. So as we just discussed just now, here it could be IP address, the next hop IP address, or it could be an exit interface, or it could be both. Okay. So for IP version 6, if you look, it is the same format as IP version 4, except we type IP version 6 route. The IP version 6 prefix and prefix length is basically the network address and the subnet mask of the remote network. And then the IP version 6 next hop IP address and the exit interface, or the distance here, which is optional as well. So the discussion today, when we talk about static route, will be based on this topology. Okay, will be based on this topology. What I would like for you to do is, you have the slides open so that you can have a look at it, and then you can sort of like highlight and see what I'm talking about. But this is a topology we are going to base the explanation on. Okay. So here we have 3 routers: router 1, router 2, router 3. Router 1 has 2 connections. Both are directly connected, one to its LAN, one to its WAN. R3 also has 2, one to the LAN and one to the WAN. This is LAN, this is WAN, sorry. And then R2 has 3, 1, 2, 3. Okay. So each router has entries only for directly connected networks and associated local addresses. Why does it only have this? Because we haven't configured any routing on it. It only knows what it is directly connected to. So for R1, it has this network, 172.16.3.0, and this network, 172.16.2.0. So you see there, 2.0, 3.0, and the local address for that network. So if you try to ping 172.16.2.2, the ping is successful. See, success rate is 100%. But when you try to ping 192.168.2.1, the success rate is 0. The ping is not successful. Where is 2.2 and where is 192.168.2.1? So 172.16.2.2 is this over here, this interface over here. So this router can ping that because there is a directly connected cable between this router to that router, that interface. But 192.168.1.1 over here or 2.1 over here, there is no connection to R1. And R1 does not have a path to this network. This network, 1, 2, and 3, these are called remote network because they are not directly connected to R1. Okay? So because there is no way for R1 to know how to get to this network, you see there is no 192 at all, so it cannot send a ping. So this is the same IP route but using the IP version 6. Okay, as you can see, they have the directly connected network. Okay, it can ping the directly connected path but not the other one. So let's look at how we are going to implement static routes. So a router learns about remote networks in two ways. One is manually entered into the routing table using static routes. Static routes, because they are manually entered, they have to be manually updated as well. They cannot automatically update. So whenever there is a change in the topology, the network administrator have to go into the router and then manually update the static route. Another way to learn about remote route is to dynamically or automatically learn using a routing protocol, using a dynamic routing protocol, whether it is RIP, EIGRP, or OSPF. Okay, so if you take an analogy, you can imagine static route to be like collecting phone numbers. Okay, you ask your friend, what is your number? What is your number? What is your number? So every friend you ask for the number and you collect those phone numbers. Okay, and you write it down in your phone or in your book. And then when the friend changes his phone number, you have to go back to the phone or the book and then, highlight that one, change, and get the new numbers in. In dynamic routing, it's about handing out a business card rather than collecting all the phone numbers. You are giving out your business card. This is my number. This is my number. If you want to connect me, this is my number. Okay. So here, static routes here, it is directly connected to these three networks. It doesn't know anything over here. Okay, so it has to have a way to connect to this. Same thing as dynamic route as well. But the difference is for static route, in creating a static route, you find out the remote networks. You find out this one and that one. Those are the ones you configure in R1. In dynamic routing, rather than go find the remote network, you tell your neighbor what networks you know. You see here? R1, he says to R2, look, I know about 192.168.10.0, I know about 192.168.11.0, and I know about 209.165.200.224. And that information he tells R2. R2 will do whatever it is that he needs to do with that information. And then R2 will also share his information. In this case, I have a route to this network, to this network, and to this network, to R1. So they will exchange information and then they will update their routing table. In static route, you have to find out what the remote network is and then configure it into your router. That's the basic major difference between static routes and dynamic route. We have seen this before in our class last week when we talked about, what's the difference between dynamic routing and static routing. So I'm not going to go through this again. I'm just going to jump forward, okay? So when do you use static routes? There are three uses for static route. One, when it is a small network that is not expected to grow. Okay, it's very small. So let's say you created a little bit of network between your friends. So that is not going to expand. So you can use static routes. Routing from to and from stub network. So if you look at the topology here, this part over here is a stub network. A stub network is connected to a stub router, where this router is only connected in one way out to outside of the network. So this is inside the network. Going out of this stub network, there is only one path. Okay, so when this router wants to talk to him, there's only one path. So this is called a stub network. And in this instance, using a static route, especially a default route, would be the best way. So a single default route to represent a path to any network not found in the routing table. So basically, you are using a default route here to say where to send something. Okay, where to send something by default. So you can use static routes to connect to a specific network, connect to a stub network. You can summarize routing table entries, which reduces the size of routing advertisement. Okay, so if you summarize a few routes and then make that into a static route, and then you don't have to have so many things in your routing table. Why is reducing the size of routing table important? Imagine if you have an address book, right? And in the address book, there are 1,000 addresses. So if you want to find one address, you have to sort of like go from the top to the bottom, go from the top to the bottom, right? Or at least go by alphabet A, or these are all A's, B, these are all B's. But it takes time because it is very large, 1,000 addresses. But if you have a smaller address book, let's say you only know 2 people, very easy to find their addresses. So the size of the routing table, the smaller the size, it's better. And in dynamic routing, the size of the routing table is what you share with your neighbor. If you have a big routing table, you're going to use a lot of bandwidth to share that information with your neighbor. And you can use static routes to create a backup route in case a primary route link fails. So you can have EIGRP or dynamic routing, and then you can have a static route as a backup route just in case the dynamic routing fails for whatever reasons. So standard static route, you have configure how to go out of the network. In this case, because it's going out to the bigger network over here. Okay. Then you have default static route. Default static route, it matches all packets, and it is used when a packet does not match a specific route in the routing table. Again, in this case, when we have a stub router and a stub network, default route here is the best choice. Okay. Default route can be dynamically learned or statically configured. Okay, you have to configure it statically, yeah, but you can dynamically learn, meaning if I have a default route to somewhere, you can use the dynamic routing advertisement to advertise the default route to another router. So default static route uses the 0.0.0.0/0 as the destination IP version for address and subnet mask. So what it means here is that it fits everything. It fits everything. It will take everything. So this will create the gateway of last resort, and it is common use is when connecting to a company edge router like this. So we have a default route here. Now remember, if you have a default route configured in R1, but no route, static or dynamic configured here, it's not going to work. Okay, it's not going to work. Summary static route is basically you are going to summarize all the information into sort of like 1 or 2 lines. For example, here in R1, if you were to create static routes for remote networks, this is remote, this is remote, this is remote, this is remote. There are 4. So there'll be 4 lines of static routes in the routing table. What if we can summarize it and make it into 1 line? So this 4 can be summarized into just 1. And there will be only a single entry of the summary route in the routing table, making the routing table size smaller. But there are basic elements or characteristics that you have to follow. One, the destination networks must be contiguous. Contiguous means it is in sequence. If you see here, 20, 21, 22, 23, so they are contiguous. You cannot have, 20, 64 or whatever it is. You can actually, but it will make it harder for you to have a summarized route, and it will not be effective. Okay. Multiple static route must use the same exit interface for next hop. So for R1, all of these uses the same exit interface, uses the same next hop IP, all of them. So for R1, he can summarize all this for. So how do you summarize a route? Basically, you take all of the routes that you have. So in this case, will be 1, 2, 3, 4. Okay. You take all the routes, and then you change it to a binary. So this will be 172, 16, 1.0, 2.0, and so on. And then you find where the 3 in this particular example, the 3 doesn't match. So if you see here, 111 matches, 000 matches, match. Here it doesn't match. So 0, 1, 1. So you have to draw a border between that. So all of this bit over here, which are the same, will be repeated for the summary route. And then for the subnet mask, all of these bits will be set to 1. So if you see here, it will give you 172, 16, 0, 0. Everything else behind this line will be 0. And the subnet mask will be 255, 255, 252.0. So this is the summarized route that will be used rather than this 3. Only this 1. So that's the benefit of having a summary static route. So how do you do it? First, list out all the summarized route. If you have a question, put up your hand. If you don't have a question, please silence your mic. Thank you. So can I continue? Okay. List all the routes to be summarized. These are the routes that is going to be summarized, and then change it to binary form. Okay, and then find the corresponding bits where it doesn't, where they are no longer the same, and draw a dividing line like this. And then the network address is given by the bits on the left-hand side, and the right side will all be 0, like this. The left-hand side, the right-hand side will be all 0s. And then the subnet mask is given by the left-hand side being all 1s. Basically, this is how you get a summarized route. Okay. A floating static route is used to provide a backup path. Okay. It is used when the primary route is not available. Now, if you remember from our discussion in our last class, we talked about the administrative distance of the routes, EIGRP, the AD is 90, RIP, the AD administrative distance is 120, OSPF, the AD is 110, directly connected route, the AD is 0, static route, the AD is 1. And the smaller the AD number, the higher the trustworthiness of that link. So how is it that a static route is going to be a backup to a dynamic route which has a higher AD than a static route? So to do that, you have to configure the administrative distance for the backup static route or the floating static route higher than the the routing protocol that you are going to use. For example, if we are using EIGRP, okay, EIGRP administrative distance is 90. So to have a floating static route, you have to set the administrative distance of that floating static route to be at least 91 or higher. So it will be as a backup. Okay. So what happens is that it will use EIGRP to work, but let's say for whatever reason that EIGRP goes down, then the backup floating static route will be reinstated into the routing table. Okay. So let's look at the configuration. But before we do that, let's just reiterate these 3 very, very important routing principles. 1, Every router makes its decision alone based on the information it has in its own routing table. 2, the fact that one router has certain information in its routing table does not mean that other routers have the same information. 3, routing information about a path from one network to another does not provide routing information about the reverse or return path. Basically, it says a router will tell you how to get somewhere, it doesn't tell you how to get back. So IP route command in the global configuration mode, IP route, the remote network address, the network address subnet mask, and then either the next hop IP or the exit interface. And optional behind here, there's the distance where you can use it to configure the administrative distance. When we talked about floating static route just now, we say that we have to increase the administrative distance of a floating static route when it is used as a backup for a dynamic route. So this is where we put in the new administrative distance. Hold on, not sure if you can see this. Okay. When you have a basic network like R1 over here, okay, before you configure your routing, okay, it only knows the directly connected routes. If you see here, the C and C, there are two routes, one here and the other one there. Same goes for R2. It has 3 Cs, one over here, 2, 3, and R3 has 2. So it only knows what is the directly connected routes. Now, if you see here, you see all the L's, but in R3, you don't see any L. It's because here, it added the, the sort of like a filter, show IP route, include C. So it's only showing you the C part. This one is begin gateway, it shows you everything. Okay. So when we have this topology and we try to ping 172.16.2.2, we are in R1. You see this R1. We ping 172.16.2.2, which is this end over here, and it is successful. Now you might be thinking, we haven't configured any routing, static or dynamic, so how can router 1 ping router 2? The answer to that is because this interface, it pings the other end of the cable. So of course it can do that. But if we try to ping from R1 to say 192.168.2.1, which is this interface over here, it is not successful because it doesn't have any way to send it. It doesn't know a path to that network. So here is an example of how we can configure, okay? So R1, firstly, you have to identify the remote networks. The remote networks to R1 are the ones that are not directly connected to R1. So 1, 2, 3. So there are 3 remote networks. You need 3 commands. The first one, IP route, the remote network 172.16.1.0, the remote network subnet mask 255.255.255.0, and then it is using the next hop IP, meaning in here, if I jump this cable, what is the IP on this side? 172.16.2.2. Okay, and then IP route to this network, subnet mask 255.255.0. Again, that is the next hop IP. And the next one is IP route 192.168.2.0, subnet mask 255.255.255.0. The next hop IP is still this at the end of that, 172.16.2.2. And just like that, you have configured a path to PC2, to this network, and to this network, and then to this path over here. Okay? So one thing about next hop IP is that when you give it the IP address, you still have to do another lookup to see where is this IP address, which interface is it. So here, the router would do what is called a recursive lookup. Okay? This is a bit bigger, so it's easier for me to show you. Firstly, it needs to send something through this. Oh, I have a route to 2.0, and it is through 172.16.2.2. But where is 172.16.2.2? Look up again. Oh, it is through serial 000. So using next hop IP address, you have to do two lookups, and it's called recursive lookup. First, a packet comes in, oh, you find the path. Oh, it's this. Where is this? Look up again to find where the interface is to send the packet. So this is what you call a recursive lookup. So here we are going to configure a directly connected static route where it uses the exit interface to specify the next hop. Okay, so same thing. Rather than using the next hop IP address, it uses the exit interface. So you are in R1. If you are going to go out R1, the exit interface would be the serial 000 here. So again, IP route, remote network subnet mask, and then the exit interface. And you put that for all three, 1, 2, 3, and you have your path in the routing table. Now, the thing about this one is that, sorry about that, the thing about this one is that you do not need to have a recursive lookup, because let's say you want a packet comes, destination is this network over here, 192.168.2.0. So it looks up, it says, oh, 2.0. Where can I send it? Oh, through serial 000 directly. So it only has one lookup. It doesn't have to have two lookups or do a recursive lookup. Okay? So far, so good? If you have a question, put up your hand. If you don't have a question, put up the peace sign. Okay. So, just now we said that if you are using the next hop IP address, it will do a recursive lookup. But in Cisco routers with the iOS version 12.0 and later, it provides an optimized lookup using the Cisco Express forwarding. And using this, it doesn't need to do recursive lookup when you use next hop IP address. So is this good? Yes. Can it always be used? No, it can only be used on routers with the iOS 12.0 and above. So if it's later than that, maksudnya older routers, not later, older routers, they don't have CEF, so there will be a recursive lookup. So now we are looking at a fully specified static route. Before this, we looked at how to configure next hop IP static route. We looked at how to configure the exit interface static route. And now the fully specified static route. So in a fully specified static route, both the exit interface and the next hop IP address are specified. Okay. When exit interface is in an Ethernet network, the fully specified static route is used. So here, this is the network over here. So IP route, the remote network subnet mask, the exit interface, the next hop IP. So you use both in a fully specified static route. So when you look at the routing table, you would see there is a static route to this remote network with that subnet mask. The AD is 1, metric is 0, and then it is via this next hop IP, which you go out through the what should I call it? The exit interface. So you don't have to do a recursive lookup here, okay, because you have both. Now that we configured the different static routes, right, you have to verify. Remember this. Anything that comes after configuration is verification, okay? So now we have to verify. How can we verify that what we did is correct? One way is to look at the routing table. Show IP route will show you the routing table whole. But show IP route static, filter it with begin gateway. It will only show you the static route within the IP route. It wouldn't show you the directly connected routes. It wouldn't show you the local routes. Wouldn't do that. Just the static. So you could see here, oh, these are the three I configured just now, which is correct and correct. Okay. Another way is to show IP route for a specific IP address, meaning here 192.168.2.1, which is here. right? And then it will show you that the routing entry is for 192.168.2.0, and then this is known or learned via static routing. The administrative distance is 1, the metric is 0. Okay, so you can get information on that to check whether or not your configuration is correct. Another way is to look at the running config file. So you type show running config. If you type show running config, it will show you the whole running config file, which is a long file. But you can use the filter section IP route, and then it will only show you the information about the IP route configuration you have made. And you can check whether this is right. So these are ways you can configure. Okay, there you go. Same thing. I just made it bigger. Default static routes are used commonly when connecting to an edge router, to a service provider network, or a stub router, from anywhere to a stub router, or stub router going out. So default route is used when no other routes in the routing table match the destination IP. So here, IP route any network, that means 0.0.0.0, 0.0.0.0, any subnet, and then you have the next hop IP exit interface. So this part over here tells us that it will match any network address. So how do we configure that? We can configure IP route, and then any network, any subnet mask, and then this is the next hop IP address. So if PC1 sends to any network, 172.16.1.0 go out here, 172.16.192.168.2.0 it will go out here, 200.200.200 it will go out here. Whatever it is, R1 will send it out here. R2 will sort it out. Okay, but on R1, anything it gets, it will send it out here. Okay, so verify default static route. Can I have a, oh, I don't have a bigger one. You can use the show IP route static. Again, it will just show you the static route. And if you see here, because we set the default route just now, it has S star. So star means candidate default, S means static. So you see that, that's the static route, AD, metric, and then the next hop IP. And it also has set the gateway of last resort. Okay, gateway of last resort is this interface over here, next hop IP, to any network. So that's how you check. Now you might be asking, configuring a default route is easy. Why are we thinking about all the other types of, different types of static routing? Why don't we just use default route everywhere? Default route here, default route here, default route here, easy. So we don't have to, pening kepala, give us a headache to think. Well, in this case, because it is a stub network, default route can work. In this case, because it is a stub network, default route can wait. It can work. But for R2, it is not a stub network. So it cannot have a default route. Which default route are you going to use? Okay, so you cannot just apply default route to everywhere because it doesn't actually make sense. Okay, you have to use it. You have to think about where to use it. For default route of IP version 6, we do have the same thing. Where was I? Hold on a second. It's sort of like jumped a little bit. My bad. Okay. IP version 6, same thing. IP version 6 prefix and prefix length. So this one will tell you the, any network, any subnet mask, and then next hop IP and exit interface. So because routers mostly can work, newer routers can work in IP version 4 and IP version 6. So when you are using IP version 6, you have to tell the router that you are routing using IP version 6. So before we configure any routing, we have to say IP version 6 unicast routing. This will enable the router to forward IP version 6 packets. If we don't do this command, even if you configure everything, it will fail because the router will not forward any IP version 6 packets. So you have to have IP version 6 unicast routing. So if you look here, it is exactly the same as the IP version 4, except the addresses here are IP version 6. See here, show IP version 6 route for R1. Before we do any configuration, it only has the local routes, okay? And LFFO/8, this is the link local address only for this subnet over here, okay? And then it has, you know, for R2, it only has this 3 and link local. For R3, it has this 2 and link local. Doesn't have any information, so you have to configure. And it also has the next hop static IP version 6, where you use the next hop IP address, a directly connected static route, where you use the route exit interface, fully specified IP version 6 route, where you use both the next hop IP version 6 address and the exit interface. So it's basically the same thing as IP version 4, except in this case, we are using IP version 6. So here, IP version 6 route, and then this is the remote network and the subnet mask, the prefix and the prefix length, and then this is the next hop IP address. You see here, .2, so ACAT4::2, that's the next hop IP address. So it will come out here, and exactly like IP version 4, it will have to do a recursive lookup as well, because it will look at this static route and say, oh, you're going that, I'm going through this, but where is this? And then you have to go back and say, where is 4? Oh, 4 is here, directly connected through serial 000. So if you notice, the process is the same, only some, you know, basic addressing and command that is different. So this one is using exit interface, IP version 6 route, remote network, subnet mask, and the exit interface. And then it will show you here the remote network, the prefix length of the subnet mask, the AD, the metric, and then the exit interface. This is a fully specified static route where it has the the exit interface and also the next hop IP address. And you use this when you are using a link local address as the next hop. So here, FE80 is the link local address. So if you're using the link local address here, you do have to give the you have to make it fully specified. So basically, if you're using the link local address, you have to state the exit interface as well. So in IP version 6, fully specified static route must be used if IP version 6 link local address is used as next hop. So what does fully specified means? You have the exit interface and you have the next hop IP address. Again, how do you verify your configuration? Show IP version 6 route, look at the routing table, look at the routing table to a specific routing information to a specific IP address or network, and then look into the running configuration file. For a default route, this is how you write 0000 dot, 0000 like in IP version 4, but this is how we do it in the IP version 6 : /0. It means any prefix and any prefix length. So here, if we see, you have IP version 6 route to anywhere, and this is the exit interface ID. You can verify that in the static route. You have S, and then you have the any here, and then the exit interface. And you can also verify by pinging an address that is away from here to see whether or not it can reach. Okay. Floating static routes. Okay, when we talked about floating static route just now, we say that the static route becomes like a backup to a dynamic route. So when the dynamic route goes down, this one will be up and running. Okay, so floating static routes have an AD greater than the dynamic routing protocol or other static routes, and it is used as a backup. How do we set this? This is how we set it. We use a floating static route. You see, this is a default floating static route. Okay, IP route, any network, any subnet mask. This is the next hop IP address, and this is the AD. This is the distance. So we are setting the distance of this static route to 5. And if you see that originally here, the static route, the administrative distance is 1, right? But once we do that, it will become, oh, sorry, once we do that, the administrative distance would be 5. Here, we have two default routes that is being configured. One is through this exit next hop IP through here. The other one is through here. But the network administrator says, I want them all to follow this. But if this one goes down, this one will go up. Okay, so that means this one has higher priority. So they put this one with the trustworthiness level of 5, so it doesn't come out in the routing table. If you see this routing table, it has a default route via 172.16.2.2 via here. Where is this one? It's not in there because it's not the best route. It has a higher AD. But let's say you switch this one off, or you cut this cable down, and then this one will go out of the routing table, and then this one will come up in the routing table. So let's test it out. This one will show you how the floating static route works, okay? So we set the information just now. We configured these two, and then we did a trace route. So we trace route R1 to the network 192.168.2.1, which is this one. So you see that from R1, it will go to 172.16.2.2. From there, it will go to 192.168.1.1 before it reaches the destination. Okay, so it went this way. Okay, that's what we configured. So let's say we shut down this interface over here. Okay, we shut down. Go into the interface, shut it down. So now it's not up. What happens to the routing table? The backup will now be in the routing table. You see that? The backup is now the one with the AD of 5 via the 10.10.10.2. And if you do a trace route, you would see if you go from R1 to 10.10.10.2, which is this interface over here, all right? And that it will go to the network of 192.168.2.1. Okay? Questions? Put up your hand if you have a question. Put up the peace sign if you have no questions, if everything is fine. Okay. Right. So here is the example of configuring the IP version 6 floating address. As you can see, same thing. And you just add the distance over there. One is going that way, one is going this way. And the one going this way, ACAT.6 here is given the AD of 5. And same thing would be how it's going to run. So this one we know already because we have seen that when we configure the connection to the router, it would have the directly connected network, and then it will also look at the local route, which is marked by L here. It tells you the IP address that it uses to connect there. So here you have 198.51.100.1/32. That means for branch, where's branch? Branch, this IP address over here is 198.51.100.1. So it tells you the specific IP address of that particular host. Okay. So how does forwarding done in static route? So when a packet arrives to R1 from PC1, okay, PC1 wants to send something to PC3, it arrives at R1, R1 looks at the network and says, hold on a second, I don't have that, but I do know that I have a default route, so it will send a default route over here. Okay, it will send it there, encapsulate it, send it to R2, and then R2 then will get it, and then say, oh, you're going to that network. It will look up its routing table and find that it has a path to that network. It will encapsulate the frame and then re-encapsulate back with the information about this, the layer 2 address here, and then send it to R3, and then R3 would then send it to the PC3. Okay, so that's basically the route a packet would take. Now, a packet will jump through a lot of routers depending on the size of the network, but this happens quite fast. So we have looked at what is static route, the different types of static route. We looked at how to configure and verify static route. Let's look at a little bit on troubleshooting static route, okay? So when you are troubleshooting, you can use these different commands: ping, trace route, show IP route, show IP interface brief, and show CDP neighbors detail. Ping is basically if you can ping the one here, if you can ping this IP over here and it's a success, yay, that means your route works. Now, one thing I would like to point out here is that it says, you see this exclamation marks? So they send 5 packets, they got it. Success rate is 100%. They send 5, they got back 5, okay? But you can also have success rate of 0%. Now, sometimes students, because they are excited, they look at success rate, they say, yes, it's successful. No, you have to look at the percent. Success rate 100% is successful. Success rate 0%, that means it is not successful. Okay? So then we can also use the show IP interface brief. This is basically to see which of the interfaces are up, which is down. So, you know, if you wrongly configured the next hop IP address to be something that is down or not configured, you can look at it here. Trace route, we saw just now how to, you know, to trace the route from source to destination, look into the routing table, and then also there's the show CDP neighbors. Okay, CDP is Cisco Discovery Protocol. CDP is Cisco proprietary, and it enables you to access a summary of protocol and address information. So these are the address information of your neighbors, and your neighbors are Cisco devices. Meaning, if you have a Huawei router connected to your Cisco device, it will not detect that Huawei router in CDP. Okay, so CDP, Cisco Discovery Protocol, it discovers your neighbors who are Cisco devices. Okay, so CDP shows command include show CDP neighbors. It will give you, like this one here, show CDP neighbors. It will give you a summary of information about your neighbors who are Cisco devices. Show CDP neighbors detail will give you a more detailed information about your neighbor. And if you want to shut this down, you can type no CDP run. So use disable CDP. So if you type no CDP run, show CDP neighbors doesn't work. Okay. So here, show CDP neighbors. If R1 is running show CDP neighbors, so R1 neighbor, there is a router R2 and a NetLab CS5. This is the device ID. NetLab CS5 is connected via a local interface. This is the interface in R1, which is gigabit 00. This is the port ID, which is the interface in the neighbor, which is the fast Ethernet 01 on the switch. How do I know it's a switch? Capability is a S. S is a switch. Okay. And then here is the platform. So we know that it is running a Catalyst 2960. So this switch device is a Catalyst 2960. R2 is a neighbor. R2 is connected to R1 on R1 serial 000. R1 is connected to the R2 serial 000. So there is two cables. One end is serial 00 of R1. The other end is serial 00 of R2. And then what is R? R is a router, okay? And it is a Cisco 1941. So it gives you an information about your neighbor. In fact, if your network is using a Cisco only, for example, and you want to draw a topology of your network, you can use the CDP neighbors. And because you can use CDP neighbors command here to look at all of the devices, it is actually a security risk. So it is good for you to disable it so that other people cannot, just use it to find out your topology. Okay. So this is an example of show CDP neighbors detail. So it gives you a more detailed version of your neighbor. So again, the device ID is R2. The address is 192.168.1.2. This is a Cisco 1841 router. Okay, the interface is 0001. The port ID is 0001. The version of the iOS software that is run in R2 is version 12.3. Okay, duplex is full. So it has all that information. So again, this can be a security risk. So it is best to disable CDP globally using the no CDP run. Okay. And to stop CDP advertisement, you can say no CDP enable. So let's look at this one problem. We have this network, we have configured it. So ping, R1 here is trying to ping 192.168.2.1, which is this interface in R1. Okay, R3, sorry, this interface in R3. So it tries to ping that, okay? The source is from here. So when it pings that one, you see this dot, 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 success rate is 0%. That means the ping was unsuccessful. So when you cannot ping, the next thing you do is trace route. So in R1, it did trace route 192.168.2.1. Let's go through this. From here, it goes to 172.16.2.2. From here, it goes to 172.16.2.1 to 2.2 to 2.1 to 2.2. So can you see this? It's just going through here. Of course, it's not going to reach this side. Okay, so something is not right in your configuration. So this one going there is correct, but this one going here is not correct. So you have to go into R2 and see what the problem is. So in R2, we look at the routing table, we see that it has a static route, but the static route is to this network, but it uses the next hop IP of this router, which is totally not connected to that router where the network is. So that is something wrong here. Yeah, I typed it wrongly or whatever it is. So you go back to the configuration terminal. Whenever you want to delete a configuration, you just type no in front. So no IP route 192.168 da 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 da. It will be deleted, and you type the new correct one. IP route, the remote network, the subnet mask, and the next hop IP is this interface instead, 192.168.1.1. And then after that, in R1, when it pings, it will be successful. Okay, so this is sort of like a way for you to find if there is a problem. First, you ping. But I think the very first thing is when you configure, always verify. Okay, done. So let's say there is trouble. The first thing you do is you ping. Ping doesn't work. Then you trace route. If you trace route can sort of like pinpoint where the problem is. So you can go to that particular router to, do any amendments that you need to do. And then you can check again. So that is static routing. We looked at what is static routing. We looked at how to configure, how to verify, IPv4 static route, IPv6 static route, floating static route. How do you set the AD in that? And then we looked at some troubleshooting and problems in there. Okay, so basically that's it. Static route, very easy. Some students, this is from experience, they tend to like to use default route all the time. It's not the best answer. Use default route where it is most appropriate. So we looked at static routes. Okay, now I'm going to give you a homework. I believe this is in the slide. Okay, so you will be given a topology after the slide. You'll be given a topology, and you need to design your network in Packet Tracer. And then you need to configure end-to-end connectivity. End-to-end connectivity means every PC in every LAN can ping the other PC, all the other PCs. So end-to-end, okay? Using static route. So round one on the topology, just use next hop IP address only. Round two, just use exit interface only. Round three, use a fully specified static route. Round four, use default route and summarized route so you can mix and match to find the best way to do it. The goal here is to reduce the size of the routing table. Okay, same topology, but you do it in different ways. So there are 4 ways of doing it. Now, you don't have to submit it, but I would really, really encourage you to do it. Okay, so it will give you a different feel about how things are. So this is the topology. You have 4 routers over here. RTA has 3 LANs in one. RTB has this network connected to it, RTC, RTD. And the .9.6 over here, that means the IP address for this one would be 192.199.168.11.6 for this one, okay? So the red one is the network address. Here, all is the network address. So using this topology, you will need to do your homework. Do you have any questions? If you have, put up your hands. If not, put up the peace sign. Yes, Len Xuan.
I have a question regarding the homework 1 and homework 2.
You mean the
previous
not,
lab,
okay.
not this one.
Len Xuan, give me a minute. Let me handle. Anybody has? Okay, I'll stop the class here for now. Okay. Then we'll discuss about the labs and whatnot.